Every day, millions of solar panels around the world capture sunlight and transform it into clean electrical energy. These panels power homes, industries, and massive solar farms, becoming one of the most important technologies in the global shift toward renewable energy. But before a solar panel reaches the final installation site, it must complete a remarkable manufacturing journey. Inside advanced solar factories, ordinary raw materials are transformed into highly engineered photovoltaic modules through precision machinery, chemical processing, robotics, and thousands of quality checks. The journey begins with one of the most common materials on Earth, quartz sand, and ends with a powerful solar panel capable of producing electricity for decades. Today, we are going inside a modern solar panel factory to discover how millions of solar panels are manufactured, from raw silicon materials to the final product ready to capture the energy of the sun. The foundation of every solar panel is silicon. Although silicon is one of the most abundant elements on the planet, creating solar-grade silicon requires an extremely high level of purity. The process begins with carefully selected quartz sand. This material contains silicon dioxide, which must be processed and refined before it can be used in solar technology. Inside industrial processing facilities, the quartz is heated at extremely high temperatures to remove unwanted materials and produce metallurgical-grade silicon. However, solar cells require a much higher level of purity. Through additional refining processes, manufacturers remove almost all remaining impurities, creating ultrapure silicon that can efficiently convert sunlight into electricity. This purification stage is critical because even small amounts of contamination can reduce the performance and lifespan of a solar panel. After purification, the silicon moves into the crystal growth stage. The material is melted inside advanced furnaces and carefully controlled to create large cylindrical structures called silicon ingots. These ingots contain the crystal structure needed for efficient solar energy conversion. Once cooled, precision cutting machines slice these large silicon blocks into extremely thin wafers. These wafers become the foundation of individual solar cells. The cutting process requires extreme accuracy because each wafer must maintain a consistent thickness and quality. After cutting, the wafers are cleaned and inspected to remove microscopic particles and prepare them for the next manufacturing stage. Inside the solar cell production area, thousands of silicon wafers move through automated manufacturing lines. The first step is surface preparation. Specialized machines create microscopic textures on the wafer surface. These patterns help capture more sunlight by reducing reflection and allowing more light to enter the silicon. Next, the wafers undergo controlled chemical treatments that modify their electrical properties. This creates the internal structure required for converting sunlight into electrical energy. Manufacturers then apply additional layers, including anti-reflective coatings, which improve efficiency by allowing more sunlight to be absorbed instead of reflected away. The next stage creates the electrical pathways that allow solar energy to flow through the cell. Highly precise printing machines apply conductive materials onto the wafer surface. These tiny electrical contacts collect the energy produced by sunlight and transfer it through the solar module. Because these components are extremely small and precise, automated inspection systems continuously monitor production quality. High-resolution cameras scan each solar cell, detecting cracks, defects, or alignment problems. Only cells that meet strict performance standards continue to the panel assembly stage. Now the individual solar cells are ready to become complete solar panels. Inside the assembly section, automated machines arrange hundreds of solar cells into precise patterns. Each cell must be positioned accurately because the performance of the entire panel depends on thousands of tiny connections working together. Thin conductive ribbons connect the cells, allowing electrical current to move efficiently through the module. Once connected, the cells are placed between protective layers. A strong glass surface is added to the front of the panel to protect the delicate solar cells from weather, dust, and physical damage while allowing sunlight to pass through. A durable backing layer is added behind the cells to provide insulation and long-term protection. The assembled layers then enter a powerful lamination machine. Using controlled heat and pressure, this process permanently bonds the layers together into a single solid solar module. This step protects the internal components from moisture and environmental damage, allowing the panel to operate reliably for many years. After lamination, the solar panel receives its aluminum frame. The lightweight but strong frame protects the edges and provides structural support for installation on rooftops and solar farms. A junction box is then installed on the back of the panel. This small but important component connects the electricity generated by the solar cells to external power systems. Before leaving the factory, every solar panel goes through extensive testing. Advanced inspection cameras scan the surface of each panel to detect cracks, defects, and manufacturing issues. One of the most advanced testing methods is electroluminescence inspection. This technology allows manufacturers to see hidden imperfections inside solar cells that cannot be detected by normal vision. Panels also undergo electrical performance tests to measure power output, voltage, and efficiency. Additional durability tests simulate years of environmental exposure, including temperature changes, humidity, and mechanical stress. Only panels that pass every inspection stage are approved for shipment. After final approval, finished solar panels are carefully packaged and transported to installation sites around the world. Some panels will become part of enormous solar farms producing electricity for thousands of homes, while others will provide renewable energy for individual buildings and businesses. What began as simple quartz sand has now become an advanced energy technology created through precision engineering and modern manufacturing. Behind every solar panel is a complex journey involving raw materials, chemical processing, automation, and strict quality control. From silicon extracted from the earth to a finished photovoltaic module generating clean energy, this is how solar factories transform ordinary materials into one of the most important technologies shaping the future of renewable power.